Hey everyone, so this video is mainly for second block because I'm out today, so hopefully this will be a decent substitute for me being in class. But if you do feel like you are not understanding and you want extra help before the checkup on Thursday, next class, please make sure that you see me before school or after school tomorrow, during advisory tomorrow, or maybe even before school on Thursday. But the law of cosines is pretty straightforward. We're going to use it if we are given an oblique or non-right triangle where we know the side, angle, and side. So we have an SAS triangle or an SSS triangle. There are no ambiguous cases with the law of cosines, so it's pretty easy to apply. We just need to basically plug and chug, making sure that if we use this formula, this is always the angle that we're looking for, even if it's not an ABC triangle. And this is always the side across from that angle. And if we're using this formula, we're making sure that this is the side that's across from our given angle, and this is the given angle. So that's really the only tricky thing about law of cosines. Let's take a look and see what we mean. Okay, so in number one, we can see we don't have a right triangle. This is an oblique triangle. It's a side angle side triangle because the angle is smushed in between the two given sides. We are looking for a side length from R to T, which is across from angle S, which would make this side little s, which is what I use in my formula. So since I'm looking for a side length, I use the side length formula for the law of cosines. I get 15 squared plus 23 squared, although these can be written in either order, minus 2 times those two side lengths, same side lengths, 15 and 23, times the cosine of the given angle, or 27 degrees. So when you put this into your graphing calculator, it should be pretty straightforward. And sorry, I'm having some technical difficulties with the calculator. And every time it locks me out, it puts it back in radian mode. So this is a good quick reminder for how to turn it back into degree mode as well. Okay, so we're going to do 15 squared plus 23 squared minus 2 times 15 times 23, and you can do it in Desmos exactly the same way, and then cosine 27. And you can see we get this big answer, and that's because what we've actually found is the side squared, not the side itself. So the very last step we're going to do is just take the square root and make sure that we round appropriately according to the directions, and if we had units, we would need to include units in our answer. We're going to skip down to number 5 next. Number 5 says to find the measure of angle A. We can see that we're given a non-right triangle. We are given another side angle side triangle, and in this case we're looking for the measurement of angle A, so I'm going to use my angle formula. However, as I start plugging in, I notice that I don't have enough information. I need to include the side length that's next to the angle that I'm looking for, and I don't have that side length. So what I need to do is apply the side length law of cosines first to find that missing side length, just like I did up here in number 1. And then once I know that number, I can go ahead and plug it in to find my missing angle measurement. So this is just a 2-step law of cosines problem, but we solve it exactly the same way. And once we find that missing side length, we plug that in. So make sure that when you apply this formula, the last step here is to take the square root. Up here, to plug this into your calculator, particularly if you have a graphing calculator and you're not using Desmos, you just need to make sure that you enclose your numerator and your denominator inside parentheses. Otherwise, it should look exactly the same. And then do your fraction, and then your denominator, cosine, whoops, I'm sorry, not cosine, 2 times 15 times 19.62. And then enter parentheses. Okay, in this case, when you're solving for an angle measurement, you should get something very small in your calculator, and that's, again, because you didn't get your answer directly, what they're looking for directly. You found the cosine of angle A. So your very last step whenever you're problem solving for an angle measurement is to take the inverse of that answer. So to solve for actual angle A, you're going to do the inverse trig function, and that's going to give you your angle measurement in degrees. And that's where we got that from. Number 7 is a side-side-side triangle. So it's again the law of cosines. We're looking for an angle measurement, but since we're given all 3 sides, it's just a single step law of cosines, so we're going to plug it into our calculator the same way we did in number 5. We just don't have to do this first initial step because we're given all of our 3 sides. The last question I want to go over with you guys in this video is to take a look at the area problems on the next page. So in 19 and 20, well, all of these at the bottom, they asked us to find the area of each triangle, which we have learned so far this formula for 1/2 AB times the sine of angle C, or the included angle. So in other words, we were looking for a side angle side triangle where the angle is included or sandwiched in between the 2 given side lengths. If we are not given that information, we need to use, in this case, because it's an SSA triangle, the law of sines to find the missing angle measurement so that we can apply this formula. So if you recall, we did problems like 19 and 20 already. Number 21 and 22 are a little bit different because here they're giving us a side-side-side triangle. And so we can still do this. We can use the law of cosines and then use this formula again. But there's a more direct formula that only uses side lengths, and it's the formula also on your flow chart given right here. And we just need to find this variable s, which is a number that we derive by adding up our 3 side lengths and dividing by 2. So in number 21, if we add up our 3 side lengths and divide by 2, we get 18.9. So everywhere we see an S, we're plugging in 18.9 into the formula, and A, B, and C just stand for your 3 side lengths. So when you plug that into your calculator, you just need to make sure if you're using a Casio or a TI that you enclose everything inside the parentheses in its own set of parentheses to extend that radical over everything. Otherwise, it's only going to take the square root of the very first number that you type. So it should look kind of like this. Oops, 1 extra. And if you round to the nearest tenth, it's just 61. And our units in this case are yards. And whenever we find area, it's always squared units. Okay, so again, make sure that you come see me if you have questions. Thank you for your attention, and I appreciate your hard work in class during my absence. And if anyone else is watching this video, way to go. Good job. If you have any questions, go see your math teacher. Talk to you soon. Bye.